Section 12.2. It is polar coordinates. Alright, so we are going to graph in polar coordinates, and the most important thing to remember in polar coordinates, it's kind of like you're looking at the Earth from the North Pole looking straight down. And so you have these concentric circles going around it. And you're going to have 0, pi over 2, pi, 3 pi over 2, and then we're back to 2 pi. And you graph everything you graph is with an r and a theta. R comma theta. R being the radius, or the number of rings out you count. And then theta is the angle that you have to go through. So example 1 wants us to graph the following points in polar coordinates. And I don't have polar graph paper here, so we're going to make do. R is -1, 7 pi over 4. And then S is 2, -3 pi over 2. So when you're graphing this, and I'm not going to draw all the rings, I'm just going to mark it on the x-axis and go around. So we want to go out one ring. That one's a little far out. And we want to do an angle of 5 pi over 4. 5 pi over 4 is going to roll around. This would be 4 pi over 4. So now I'm at 5 pi over 4 with a length of 1. We're going to mark it as a length of 1. And I'm just going to call it a 1. We're not going to deal with the things here. The next one we want us to graph is -1, 7 pi over 4. Now the trick to that is 7 pi over 4 is here, whoops, but I only can go out 1, but it's -1, so I go straight through, and -1 comma 7 pi over 4 would be 1 out on this ray. So this is R. This guy would be Q. And then S is going to be out 2, -3 pi over 2. So that negative says to go around the curve clockwise. So starting at 0 and running clockwise, you're going to go around, and I'm going to, can't draw on top of this one too nicely. I'm going to go around like this and say this is -pi over 2, -pi, -3 pi over 2, and you have to go out a length of 2. I'm going to call that 2. And you can see it better if you look in the textbook. It's a little easier to look at. If you end up with one, I don't see where they did one like this, but what if I do, let's make them both negative, QRST. How about we do -3 and -pi over 2. So not only are we going backwards to -pi over 2, but then we have to go through that line right there. Right there is what I'm talking about. A length of 3, which is going to put me all the way up here, and this would be a length of 3. So our conversions for this are things that we already know. If we have r comma theta for polar and x comma y for rectangular or Cartesian, we know that x is equal to r cosine theta, and we get that by looking at the right triangle where this is theta, this would be x, this would be y, this would be r. We also know that y is equal to r sine theta. We also know that by Pythagorean theorem, x squared plus y squared is r squared, and the tangent of theta is equal to y over x. Now they always give us tangent of theta, but it doesn't really make a difference. You can use any one of your trig functions to get that. So, for example 2, they want us to convert the point, express the point with polar coordinates. So the point is 3 pi, 2 comma 3 pi over 4. Express the point with polar coordinates in Cartesian coordinates. So this is your r and your theta, and you're trying to get down to x and y, so use those first two formulas. And the other one is y equals 2 sine of 3 pi over 4. So you need to draw yourself a picture, figure out where 3 pi over 4 is. 3 pi over 4 is going to be here. So my reference angle is just pi over 4. I'm in the all students take calculus, so I'm in the sine quadrant. So this guy right here is going to come out negative. It's going to be 2, and then pi over 4 is negative square root of 2 over 2. And the y version is going to come out positive, so 2 square root of 2 over 2. X is negative square root of 2. Y is positive square root of 2. So the point they're talking about is negative the square root of 2 and positive the square root of 2. The book does a good job of explaining. It's on page 736 in the textbook. They pick up a polar graph, a circular graph, and plop it right on top of a rectangular graph. So you can graph them on a rectangular graph even though it's polar. You just got to pay attention to your angles, which is what I graphed in the graph that I just did. I did a polar graph. This length is 2. Part B wants us, what is it? To take this Cartesian point. So we have part A. Part B, the Cartesian point Q, 1, negative 1, and put it into polar. So this is x and this is y. So we need the r and the theta. Well, according to the other two formulas, x squared plus y squared is r squared. 1 squared plus negative 1 squared is r squared. 2 is r squared, so r is the square root of 2. And then tangent of theta is y over r. When is the tangent negative 1? Well, it happens in two places. R depends on how you write it, though. There's lots of ways to write these. It's negative 1. I can draw the picture if I need to. Well, I don't need to. It's just that it happens right here in this quadrant down here. So it's going to happen at negative pi over 4 if I want to go backwards. Or I can call it 7 pi over 4 if I want to go forward. Or, because they're exactly the same thing. Now, remember, there's infinitely a number of ways of writing this. I didn't have to write it like this, but I could write it as square root of 2 comma 7 pi over 4. Or I could call it square root of 2 comma negative pi over 4. Or I could keep on going. I could wrap around twice and call it 15 pi over 4. That would also work. So it just keeps on going. Now we're going to convert equations. So we're up to example 3. It says, convert the polar equation r equals 6 the sine of theta into a Cartesian equation and explain the graph. Describe the graph. So what do we know? Well, let's square both sides, because to get to x and y, I don't know anything about r. I only know about r squared. So if I square both sides, or multiply, no, I don't want to do that on a square. I want to multiply through by an r. Let's multiply through by an r. That'll be easier. R squared is 6r sine theta. R squared is x squared plus y squared. The r sine theta is y. This piece right here is y, so this is 6y. So if I bring everything over to one side, I have x squared plus y squared minus 6y is 0. If we complete the square on the y portion of this, half of 6 is 3, 3 squared is 9, add it and subtract it. I end up with x squared plus y minus 3 squared equals that 9. We'll bring that 9 over. That would be the equation of a circle. center at 0, 3 with a radius of 3.